friends, I Rahul Agarwal, Associate Professor in Biyani Group of Colleges, delivering video lecture on special functions on behalf of Group KPU. Friends, in our previous video lecture, we will discuss about constant function, identity function, modulus function and signum functions. Now, in this lecture, we will discuss about three special functions. First one is square function, second one is reciprocal, third one is step function. At first, we will discuss about square function. So first we are taking square function. What is a square function? A square function, very simple. Fx can be defined as x of square. It is our square function. If we place x, then we get x square. For example, if I place, then I get 4. If I place minus 2, then also get plus 4. It is known as square function. Now, we have to design graph of this function. The graph of this function can be represented as same process, here x and here x. Okay. Now what is the process? If I place 0, like f0, then we get 0 square. So at 0, it be 0. If I place 1, 1 square 1, at 1 we get 1. If I place 2, then we get 4. If I place 3, then we get 9. Similar in minus direction. If I place minus 1, then also plus 1, minus 2, then also plus 4, minus 3, then also plus 9. So graph can be represented in the way, this way. So it is our graph of square function. Now we will tell about domain and range of this function. Domain, second one is range. What is domain? Domain is possible value of x. What can be x? X can be 0, x can be negative number, x can be positive number. So its domain be R. R for real number. Second one is range. What is the range of this function? Range be only in positive direction or 0. No value of fx in negative direction. So its range be non-negative real number. Getting this point? So in square function, domain be R, range be only in positive direction in 0, no value in negative direction, so range be non-negative real number. This is our square function. Now we will discuss about reciprocal function. What is reciprocal function? So next topic is our reciprocal function. What is reciprocal function? Reciprocal function can also known as inverse function. Reciprocal function can be defined as also inverse function. Inverse function means fx is equal to x minus 1 or 1 by x. So it is the reciprocal function or inverse function. Now we have to design graph of this function. The graph of this function can be represented in the following way. Graph process, designing graph process be same, x and fx. So graph of reciprocal function be as x, this is fx. If we increase value of x, then fx be decrease, since 1 by x. If x be increase, then fx be decrease. So as well as x be increase, fx be decrease. But fx can't be 0. 1 by 0 is infinite. So x can't be 0. and fx also can't be 0. So when we increase value of x, fx be increased, so graph can be designed as x is increasing, fx is decreasing. This graph never touch this. Okay, same process in negative direction. It is known as graph of inverse function. Now we will tell about domain. Second one is range. Domain means possible value of x, on which values function be defined. Here x can be anything, positive, negative, 0, but x can't be 0. Here x can't be 0. At 0, no value of fx, since 1 by 0 is undefined. Okay, so graph, by using graph we can define domain of this function. In domain never can't be 0, so domain be r minus 0. That means any real number except 0 will be the domain of this graph. And what is range? Range means possible value of fx. Fx can be anything, but fx can't be 0. So range be also same, r minus 0. Getting this point? Now we will discuss about step functions. So what is step function? Step functions is a special name which is taken by its graph. We will see in this graph that we get step by step process. So it is known as step function. There are two types of step functions. First one is floor function. Second one is cell function. So we will discuss both functions. First one is floor function, second one is cell function. At first, floor function. Floor function change value in lower value. It can be shown as fx is equal to x, and this one, this symbols is used for floor function. Floor function convert value into integer. Which integer? Which is less than 2x. Which is less than 2x. That will be the floor function. How? Example like 4.6. Convert into integer which is less than 4.6, that is 4. Like 5.1, then we get 5. It is our floor function. Now we have to design graph of this floor function. So graph can be shown as x and fx 0, 1, 2. We are taking some sample values. Here x is positive, in this direction x be negative. So -1, -2, -3, -4. In upper direction x be positive. So fx1, fx2, fx3, fx4. Here fx be negative. So fx be -1, -2, -3. Now how can we design graph? Floor function convert into integer which is less than to the value. So if any value is between 0 and 1, it convert that into 0. So if any value is between 1 and 2, then we get 1. 2 and 3, then we get 2. 3 and 4, then we get 3. In this process graph we proceed. In negative direction, any value is 0 and -1. -1 is less than, so it converts into -1. Between this, it converts into -2. Between this, it converts into -3. Between this, it converts into -4. Getting this point? So it is graph of floor function. Now we have to define about domain. Second one is range. What will the domain? Domain means possible value of x. Here x can be positive, negative, 0 and also in decimal points. So domain be real number and range possible value of fx. Fx is always an integer, no value in points. So range be integer. Z for integer. It is our floor function. In similar function, we can define ceil function. No change, only it convert into lower value, it convert into upper value. So we can change floor function into ceil function in the following fashion. Here we will put ceil function. Ceil function convert value in upper value, like, but floor convert into below value. Floor convert below, so sign is below side. Ceil convert in upper, so sign be this one. It is a symbol of ceil function. Ceil function also convert value into integer, which is more than to the value. Convert value into integer, which is more than 2x. Which is more than 2x. If in this value I apply ceil function, then what we will get 5. In this value, we will get 6. Getting this point? So minor changes will be there in this graph. Here, in floor function, between 0 and 1, we get 0, but in ceil function, we get 1. So changes in the graph can be shown as between 0 and 1, we will get 1. So graph be this one. 1 and 2, we will get 2. Between 2 and 3, we will get 3. 3 and 4, we will get 4. Getting this point? In negative direction, between -1 and 0. 0 is more than, so we get 0. In this process, we get -1. Here we get -2. Here we get -3. The graph can be shown as step-by-step process. So these graphs are known as step function. No change in domain and range. Same concept, domain be real number and range be integers. Getting this point? So it is our step functions. In this video lecture, we will discuss about 3 topics. First one is square function, second one is reciprocal, third one is step functions. Step functions are of 2 types, floor and ceil. Thank you. Thanks for watching this video. Please like, comment, share and don't forget to subscribe our YouTube channel and visit our website gurukp.com. Thank you and thank you.